Hello there again. Hi. It suddenly just got very windy in here in my house. Uh, Now I want to go on, continuing on. Actually, I did. I recorded an entire video, which I thought I had uploaded last night or early this morning, and I accidentally overwrote it. I thought I'd moved the file, the WMV file, to a different directory, and then but I hadn't, and I started recording just a quick video for something else, and that overrode it, and so now I got to do it again. I'll try to remember what I did. And I wanted to make a point too about the this whole business about starting at the end. In fact, that thing, by the way, is the thing I mentioned in the tutorial to do with this virtual dub. This here file. It's an MPEG-2 file. See? Anyway, I'll look at that later. Look at that on my own in a minute. Starting at the end, you see this calculator and aggregation client. These two projects are projects that I downloaded from what's that site called? Not SourceForge. They were sending me all this spam, but that stopped. I kept pressing the report spam button. Code something. Anyway, I got this example, and this is an example of starting at the end. First, here's the usage of the aggregated object. If you can understand this code. Okay, here's DLL main. This is using something called the ATL, Active Template Library. So every module, like a DLL, is a module, right? Program or DLL, something in memory, has it. For each one declares a global variable to represent the object. Does some initialization stuff. Now, the complex math. This is the implementation part. The header has some things you write down. You just write these things down without understanding, and then to use it, you write this declaration down. First, you co-initialize, of course. This is on a button press in a dialog. For example, uses a C dialog aggregation client. Push the button, co-initialize, declare a string, declare a long result, declare a complex math pointer object like this, and then just call divide. Actually, I should build this. I want to go build. I have to get rid of this other stuff just to not pollute my workspace. I'm still okay. I got two things. Now, what's my build configuration? See, because this has. Oh, I changed it. Okay. Debug, I think, should work. It might build. I hope so. And then I'll show you that all of the work gets done on this line, and by this line it's ready to go. So that's an example of starting at the end, because you don't know. It doesn't explain to you how this step works. It only tells you how to make that step work, which is not, well, it's learning how, but it's not learning why, I guess. Why does this line have the desired effect? How does it end up giving us a complex math? Now here he's declaring a simple math, which is a different kind of object, and the extraction of the simple math from the complex math is done via an assignment operation. Okay. Again, all of the work in this case is being done here. All right. Now, I don't know why it can't be done on the declaration line, but maybe it can be. We'll try it. And here he's using the simple math add, and you'll see if it works. I have to be honest. This has to be done. I expected this to take me into the complex math DLL, and then jump to the simple math, which would have already registered. I don't know if it is registered. Do I even have it? Let's see. Where is this thing? DLL. Here's the DLL for the simple math, I believe. Yeah, calculator. This here is just some, object files and whatnot, and in the end, the DLL, I think, in here. Here they are. Complex calculator DLL. It may or may not be registered. We'll find out. It is. This will fail. Oops. So if I run this thing, on button. Okay, so you press this button, and I'm going to put a breakpoint in here. Then it seemed to work, so it must still be registered. Okay, so it did work. Now the question is, step in or step over? I'm going to step over this line and step into this. That puts me still in the exe file. Oh, okay. Now I'm in the exe file. Oh, no. It says exe divide. How come I ended up here? Type layer. It's not using that DLL at all. Let's see now. Oh, wait a minute. Raw divide. Let's see where that goes. This is an H result. Ah, okay. Now we're in the DLL. Complex calculator. DLL. Alright. So that worked. Now, I'm going to step over this again. Over. And over. I just want to see where this takes me. Same line, right? In terms of the pointer. So now where does this take me? Here's the com call to raw add, which didn't take me anywhere. So therefore that must have taken me into the other DLL, which I don't have the source for. And so it just jumped over, didn't fail, so it worked. Now, the problem with this code is that how did I end up in here? My question would be, and I don't know, really, to tell you the truth. I don't know how this ended up there. Because it's been compiled into that code, this code, and this code has been compiled, part of this code has been compiled into the executable, right? All of the steps that you have to do. But what are those steps? I don't know. It's too much. It's too close to the end. Like, suppose now I step into this instead of over. Okay, create instance, class ID is the complex math ID, right? That makes sense. And P outer something. But this is a member function of something. Where am I? Comp imp. Do I have that here anywhere? Or is that in the... Where is this? Yeah, oh no, okay. This is a standard header, right? Now, one could step through all this, but it's not rocket science. If you just look at it, there's create instance, depending on if it's local server or remote server, and class context. If class context, oh, this is a bitwise thing. If class context includes local server or remote server, so that's true. Create instance, class ID, P outer, context, 17, not sure. Making an I unknown thing. Then OLE run. Let me see, I don't know what this stuff is. I understand this sort of. Right, makes an instance of an object. OLE run. Okay, it doesn't step into that. I tried to step into this, but it didn't show me any source. It succeeded all right. Query instance. Okay. Now, what's this? Get IID. Again, that's in the runtime line, like in the, you don't write this code. So that's just a query instance. But I don't know, what is this guy ID? It's a complex calculator lib. That's included in here, definitely. Alright, that's supposing that worked. Didn't fail, so we're okay. So we declared the object. Now, how that worked, I don't know. Surely a DLL must have been loaded. Here it is. Calculate both of these DLLs were loaded. Okay, it makes sense. But it happened on, we didn't have, you don't have to do it. You just declare this. And this implementation, again, we're in the runtime, the active ATL stuff, which to understand how they've structured all this. It doesn't tell you. The example doesn't tell you how this is structured. I can see in the end, right, that the arrow operator has been turned into a function call, right? Sorry. It's not a function call, it's still a com call because there's a this pointer involved. There has to be in order to make this call, right? The object I've been handed is like there's a this pointer involved here, and although there are no no member variables being accessed, this is being used, right? So there is a this pointer, and so therefore it doesn't follow, but it turns out this is a this call. I could pass in members of my complex math thing. I'm not sure how it works. And now that's good enough, but it doesn't help us understand. What happens on this declaration line? Nothing, right? That's good. Assignment operator equals, which is a template function, and what's this other? How did I? What version of this equals am I using? I don't know. Maybe it'll say in the call stack. It does, but you see how long that line is? Okay. Alright, it's given me the name of the version of equals that I'm using. But the name is so long it's hard, I can't make it out what it is. It's too complicated. And another example of something that's too complicated, but that we can handle anyway, just barely. Where am I? Not there. Where are we? Contest, devices, utils. Okay, so I included the device manager project, and I have included common. And is that it? And then utest. I think that's all. Maybe. Okay, now of course I don't have any aggregation going on yet, but this here is a situation which is too complicated. Too complicated for to step in at were we starting at this point. Now let me just show you what I mean. I don't even need this namespace. Oh, I'm going to add another thing, even though we don't need it. The simple math DLL. What is it? Oh, DLL test. Devices, sorry. Real math. Mine is called real math. I'm not going to build it. But I just want this here so that I can put a breakpoint here. Alright? Oh, I have to do something with my object. In terms of what the debugger gives you, it would be, I put a breakpoint the way that the other, in the DLL, sorry, in the function that would be called, if I pressed F8 and this were a COM object and I placed a breakpoint, if I just press step into, it would do something like this. Okay, here I am in create device, because that's the function I just called, right? You see what I'm saying? That's too complicated a step. There's something happened that we missed. Well, then you press the disassembly and you run it to here, and then it takes you to another. Oh, let's see my log. Then you end up in something in the ATL's headers, right? Here's my version of ATL's header, but this is an indecipherable line unless you've actually gone through all the other steps, where it was a great big complicated thing, and I had number defines for all the implementation names, right? And as I told you, in the end, it all shrinks down to almost nothing. And here's what it has shrunk down to. I don't have any more code in here to do with that. And there's actually, I don't need this. Let me get rid of it. Nothing. I have nothing in here. Except dev manager. So I can take dev manager and put that here. And get rid of this function, this file. Not the name. Delete. Still build, should be fine. There's no create instance in here. It's in here. I just moved the function into this header file. And there's only one. Release must be left manager. Missing something? There was nothing. Oh, there is one more. Well, to include here. This one. I think that should do it. These ones, these files shouldn't be in the same place. I've got this mixed up now, because these are the specific interfaces that one might design a DLL for, like this, whereas these are common things. In any case, that doesn't matter. if you recall, previously I had number defined a bunch of things like that I got from gotten from dump bin to generate, for the symbol names. But now I've managed to build a symbol decorator function that uses a template. It is a template function and takes a type as one of its. Well, here it's not an argument; it's just passed in the angle brackets. This is the version of this function I want, and the function, what it does is it locates for this type the using runtime, using the RTTI stuff, I'll show you, called type ID. There's a thing called raw name. Now this one actually doesn't produce a memory leak. It can't produce a memory leak because if you look at this code, the string itself, raw name, resolves to this address, okay, in memory. And if you go and dump bin the program and look at dump bin's output, that's in another read only utest. It's in one of those read only data areas. It's not a copy of anything, and it's not malloc memory, so there's no memory leak. It's just like one of those virtual function pointers or tables. I fixed my searching here. It used to take forever, but now I can search through these files quickly. See, I'm all the way down to this line. That's 4D. And here's another 150. Oh, maybe it's not read only. It's up here, I think. It was 4. Oh no, it's in here. It's in this area. 4F6050. Oh, it's read write. I'm wrong, sorry. Okay, it's read write, but it's part of the program image, right? And so that means that you don't need to malloc anything because this has been written in by the compiler. All right, the compiler built this table and inserted it into the program image. That's what we're looking at. Dump bin, right, of the EX. I'm not looking at the image of what's currently in memory in this running program. This is just from the executable file, but it shows you what will go into memory and where. And 050, where we're going here, was it? 4F6050. 4F6050. That's here. All right. Now it has something to do with real math, right? The way this function works is tell me what the type is, and tell me what the name of the symbol is, and I'll give you its decorated name. So I pass in this symbol. As far as I know, this is going to be compiled, depend on what compiler you're using. With this compiler, if I want to get the right name out, I have to put question mark, the name of the symbol, which is called create device. That's the function exported from the DLL. Okay. I'm gonna, I'm gonna agree with myself that I'm always gonna call it create device. Okay. I have them for my other ones, but I'll just change them to all be called to all use the same naming convention, and the type of thing returned is whatever this type is. Now, if you look at this here, this doesn't say, well, it can't say real math. It can't say create device because that isn't supplied. That part I've just agreed with myself that the DLL implementations must make a function whose name is that. Okay, and so therefore the symbol name can be constructed from the type of function name. The type of function it's a bool C type function that takes a pointer to at whatever. In this case, an real math. So using the type ID's raw name thing, which locates this position, so the compiler inserts this position here into my code, and at offset raw name from this position, which is here, it turns out, because if I run up to this point, I'm on this point. See this string anonymous? If I step over, it says .p6, and that would be here. And the dot is an actual dot. It's a 2e dot, right? That's a period. .p6 a, etc., is the raw name, but there's no. I know just by experiment that it should be. If I go up to past the underscore, all this part's the same. In fact, everything's the same following the 6, but I'm not sure. So I'm passing in my symbol, I'm including everything up to and including the underscore, and I'm asking it to cut off this many characters from what it gets, because I've looked it up, and that's how I can create a decorated name from a type and a symbol name. Okay, I know the name of the function. I know that just from experiment, for this compiler, that if I take everything from the underscore onwards, that part is the same as the exported function from the DLL, which was built with this compiler, right? So there is a compiler dependency here. But it doesn't matter, it can be worked out. Right? If I change compilers, then I'll change the way I call this function. Now I'm actually tracing it out after I glue these two together. Right? What I'm doing here is I'm starting from offset 5. Starting from offset 5, whatever I got back from raw name, so 0, 1, 2, 3, 4, 5, that's the capital N. Add this bit that I've been told to add, and return the result. So this is the constructed decorated name for the function export, which should contain the function that will build me the object. Now I can run through this here, which attempts to locate that export from the DLL, finds the DLL name in the registry, right? again, using the type name, which I called scoped name, right? Sorry, dev name, excuse me, dev name, which I have extracted from Q, the function export type, which I just know what its export type is. In fact, I don't even need to put this second parameter, but I have anyway. A DLL name is located in the registry under a certain key, and I now try to find out what that name is, and I have. It's here under stir DLL, which I entered in, which this will ask for if it doesn't find it. Sorry, I haven't gotten it yet, haven't I? I will get it. Here. What? Haven't I had it already? Stir DLL. Oh no, I'm getting it twice. Oh, I see. I'm getting it twice for some reason. My device stir DLL. How did I end up with it twice? I just made this one for some reason. I probably just got r.get. Oh, here. Oh, I'm dumb. I don't need to get it again. So let's fix that. If it should be just stir DLL. That's not empty, right? If this failed, oh, I see. But that's okay. It'll be put into the right place. As long as I do that here. If we cannot open the key, or we failed to get the value, or the file found doesn't exist, if we fail to open it, then we create it. That should be a separate case, I think. But anyway, if we do bring up a dialog box, I shouldn't use stir result. I should use stir DLL. I don't need to declare it. Oh, is that what it's called? No, it's the same name, and I'm fine. Okay. It doesn't matter, does it? Right? It's not much of a savings, is it? But I don't want to have two versions of the same data, right? Then there's a possibility they might get out of sync. If everything here does succeed, right? Then stir DLL that's capital. Then stir DLL, that's the right name. Alright, so now it goes through this thing. This here, previously I had number defines for each DLL. Each DLL's exported function that creates its corresponding object. Now I've changed my mind, and I want to standardize one section of these for these things, and that is the create function should have a specific name. Now, is it already in here? Cancel. Where is it? Add existing. Oh, it's add existing project. Sorry. So these should be called create device. That's all. And then this will work for all of them. The exported name will only depend on the type of object, nothing else. So therefore, given just the type, I don't need to write any code for this function, which becomes this function. You see, this is a redirector. This is I want to say create device in the DLL. Now what's there? It's probably a HMOD. Well, how did I? Oh, I have it here. I don't need another copy of that either. Oh, it's the string. The string. It's their DLL. Everything fine again? Great. Okay, whatever. Now this is a very quick and dirty conversion to multi-byte from wide character or do nothing, right? It doesn't matter if it's wide characters or if it's multi-byte. This at the end, this thing that I'm passing to get proc address is not wide characters. Don't know why, but if I compile for Unicode, maybe I'm wrong. Where's the declaration? Maybe there's an A. See? It's in winbase.h. How come there's no T like A? And I'm glad, actually. But, well, I'm glad that when I hit F11 on this, it won't take me to a number defined. But I'm not glad that I have to convert this to multi-byte sometimes. Alright. Eventually, as we get into here, and the name of the name of the export has been worked out by the type. We load the library, and this tpfget is the same as this. In fact, here it is being passed in. That's the second argument to this function. I don't really need that because I know that it's a type, but whatever. And call the function, call get proc address with the provided name here, with the regular C string, and return the address of the function. Call the function and return and pass in the pointer to the interface we were given, which brings us into the DLL, right? Making a my real math particular type of real math object. which returns, and all that happened in this one step here. This here redirected in one single step this create device to this create device, exactly the function I wanted to call, right? But a lot of stuff happened in the meantime, and it would be no good to start at this point and having not gone through the process of designing this function first with a bunch of number defines for the strings and the device names and everything. And now I realize that I could replace this. I could put this code right in here. I don't need to set this first redirection. This takes the same arguments, except it's got this string. But I can generate that string in here, so I can get rid of this do. Now this type, I know what type it is, so I can put an angle bracket here, and you see it's just reducing down and down. But we've seen it happen, and so we understand what's going on. All it does is locate a function of a particular name in a DLL that it finds in the registry. Here, in fact, the name of the registry key being constructed from the type of object that we want. And here's where to find the creator function, this DLL, and we know the name of the export. Alright, so now we have, let me start checking the time. Okay, we have our simple math, and we have a great way of making these new things. I don't need to touch this project anymore, right? In fact, I should take this and turn it into, oh no, yeah, that's true. It doesn't really do anything anymore, except for that add the reference manager. That's all it's got, and something to do with RPC. But as far as this math thing, there's nothing more. Well, there may be more later, but there's nothing to do in here. If I make a new object, I don't need to touch this. That was my goal, and initially, and now it's been achieved. What I want to do is think of a way in which to extend, to make an extension of this math object. Let's say that implements the same functions as a real math, and it, but not deriving from real math. I would like to do complex math, meaning I would like to have an interface like this, where these, instead of being doubles, are complex numbers. Okay, so that means we need a complex number type. It's not hard to make. If you recall from high school, the definition of complex number. Complex numbers. I'll give you a definition, a working definition. For a complex number. Definition of a complex number is defined to be an ordered pair of real numbers. So we know real numbers. Written, let's say, A and B, like that, with the following two operations defined, or with the following two operations. That's right. With the following two operations. As I want to say, defined as follows: with two operations called plus and time. I don't know how to make it look quoted. So there's one operation called plus, so we need to make an operator, binary, defined as follows. If, let's say, x is a complex number, say a and b, like the one above, give another one y, c, d, then the definition, well, first, x is equal to y if and only if a, in real number sense, c and b equals b. So we have an equality, a rule for equality. These two things are equal if their corresponding numbers in the brackets, just like vectors, are equal. And x plus y is defined this way. It's defined to be the complex number a plus c, comma, b plus d, right? And x times y is defined to be the same thing. That'd be a, b, no, minus ab, and cd minus ab, and ad plus cd, no, not c, bc. BC plus AD, whatever, the cross pair when you multiply. Let me just make sure that's right. So in particular, the number 0, 1 called I, it's usually given the name I, we're not using spaces, has the property that I times I equals, we use the middle, use the rule. So this is A and B, in this case, is equal to C and B, A, B, right? This is 0, 1 twice. So I'm giving the rule CD, which is this times, can't have CD, completely wrong here. It's not AB, it's AC, sorry. And this is BD. And BD has the minus sign. And AC has the plus sign. Sorry about that. And the other one is, no, that's incorrect. It should be, the cross terms are AD and BC. Well, it is right, for the second part was right. AC is 0 times 0, which is 0, minus BD are both 1, so that's 1, comma, and the cross terms are 0, right? AD, this is a 0 here, so that's 0, and C is this one, which is 0, so that goes to 0. Equals minus 1, comma 0. Okay, and that's if we wanted to, we could call that the number, the real number minus 1, right? The real number because we could represent real numbers in this form, with the second part always being equal to 0. In that case, multiplication becomes, if B is always 0, right, then you just get AC, so the first times the second, and so the first part becomes just AC, whatever, AC, and B and D are always 0. If B and D are always 0, then this is 0 and this is 0, and we get that the same rules for multiplication as we do for regular real numbers. Similarly, for addition, this remains 0, and since the second part is 0 for all operations, we can represent real numbers as complex numbers with a 0 for the second parameter. Alright, so therefore, if we have a real math, we can construct C with the complex numbers from R. And we have R. So we can use a real math object to build our complex math, and we can also find a way to give someone a pointer to a real math object that just uses doubles instead of this class that I haven't built yet. But I'll make it. It should only take 10 minutes. Okay, see you then.